We are continuing with part 3 of chapter 3, section 3.2, and we will begin with budget constraints. The next part of consumer theory is the budget constraint. Now, a budget constraint can be defined as constraints that consumers face as a result of their limited incomes. A budget line is a useful device. It represents all combinations of goods for which the total amount of money spent is equal to the income. So, what does that mean? Let's look at equation 3.1. So, in this equation, let's identify the variables we have. I represents the total income. F and C represents our two goods and the quantities thereof. So this represents food and that represents clothing. And P with the subscript F and P with the subscript C represents the price of food and price of clothing respectively. So this portion here represents the amount that would be spent on food, and this represents the total amount that would be spent on clothing. And we are saying that the total amount of money spent is equal to the income. We are ignoring the possibility of saving. So the entire income is spent on the combinations of food and clothing. Let's use a table 3.2 as an example, right? So you are given $80 per week as income, and the budget line is given as if plus 2C is equal to $80. So from this, I can infer that the price of food is $1 because the coefficient of this variable f would be the price. And since it's not shown, we know that this coefficient would be 1. And here the coefficient of C is the price of clothing. And we can see that it's 2, so that would imply that it's $2. And our total income or your total income is $80 per week. So that is the budget line. And the various market baskets in this table is associated with this budget line. So what does this table give us? Well, it gives us, like I said, different market baskets. So therefore, different combinations of food and clothing that can be obtained with the total income of $80. So let's look at these various combinations that can be purchased given the prices of the goods and the income. So if you were to spend the entire $80 on only clothing, and we know that clothing cost $2 per unit, then the total number of units you would be able to obtain would be $80 divided by the price. That would give you 40 units of clothing and 0 units of food. So that would reflect the one intercept of this budget line. And if you were to spend your total income of $80 on just food with a price of $1 per unit of food, that would be 80 divided by 1. That would imply 80 units of food and 0 units of clothing. The combinations B, D, and E are intermediate or points along this budget line where combinations of food and clothing are purchased. So in this case, we can see that if 20 units of food are purchased at a price of $1, that would give us $20, and 30 units of clothing at a price of $2 per unit, that would give us $60, and 20 plus 60 would give you your $80 total spending equal to your income per week of $80. Similarly, 60 units of food times 1, because that is the price, plus clothing at $2 per unit times 10 would give you 20. 60 plus 20 would give you your $80 of spending equal to your income. Right, so that explains the table 3.2. Now, figure 3.10 illustrates the budget line or the information from the table 3.2. So a budget line describes the combinations of goods that can be purchased given the consumer's income and the prices of the goods. Now we are still plotting clothing on the vertical axis and food on the horizontal axis. And the budget line is the budget line that you saw in the previous slide, given as F plus 2C is equal to $80. And we saw the different combinations that can be purchased given the prices of the goods and the income of $80. And we saw the two extremes or the two intercepts would be given by if the full $80 was spent on only clothing per week, it would be the 80 or the income I divided by the price of clothing, which was $2, and that would give you your vertical intercept of 40. So I divided by PC, your income divided by the price of clothing, would give you your vertical intercept. And similarly, your income divided by your price of food would give you your horizontal intercept. So 80 divided by the price of food, which was $1 per unit, would give you 80. So those are your two intercepts. B, D, and E represent the other points or market baskets that was reflected in the table. Thus, the budget line is a straight line from A through to G with a constant slope, and we will see that is given by the ratio of the two prices. Now, as you move down the budget line, less is spent on clothing and more is spent on food. And we know that clothing costs $2 per unit and food $1. So half a unit of clothing is given up to get 1 unit of food. We know that the slope of a straight line is given by your change in y over your change in x. And in our case, our change in y would be the change in clothing over our change in x, that would be our change in f. And the slope would measure the relative cost of food and clothing. So if we look at the slope between B and D, we will see that the change in C is 10 and the change in F is 20. So it's negative 10 over 20, which is minus a half. And we know that it's negative because it's downward sloping. So the slope is therefore minus a half. But if you look at it, it is also given as the ratio, the negative ratio of the prices. And it is always the negative of the price of the good on the horizontal axis divided by the price of the good on the vertical axis. So in this case, the negative of the ratio of the price of food divided by the price of clothing, and that will yield the slope of the budget line. You can see that equation 3.2 is the equation of a straight line, and it is essentially having rearranged this equation over here, making C the subject of the formula so that it would be the equation of a straight line. Now, I over the price of clothing, your income over the price of clothing, this represents your vertical intercept. And this over here represents your gradient or your slope. And similarly, you could find your horizontal intercept through rearranging, and that would be your income over your price of food. We will now look at what happens if income or the prices of the two goods change. In figure 3.11, we will look at the effect of income changes. Now, a change in income with prices held constant will result in the curve shifting in a parallel manner and the slope is unchanged as the ratio of the prices has not changed. The vertical and horizontal intercepts are going to change depending on whether income has either increased or decreased. So initially we have L1, and L1 is our original line. So there will be a change in income with prices unchanged, and we're going to see a parallel shift of this curve. So now in our first scenario, let's say there is an increase in income from $80 to $160. We can see that the budget line has shifted outward to the right, and it is a parallel shift. So the ratio of the prices has not changed. However, income has increased. And as a result of that, we can determine what the new vertical and horizontal intercept would be. We would still say 160 divided by the price of clothing, and the price of clothing was $2, hence 80 units of clothing can be bought, and $160, the income divided by the price of food, which was $1, would result in 160 units per week of food. So you can see an increase in income results in a parallel shift outward. However, if there is a decrease in income, income falls, and in this case, it falls from $80 to $40 per week. We now see that the budget line shifts inward. Again, it's parallel as the ratio of prices did not change. The price of the two goods did not change. However, we have different intercepts, and it will be calculated in the same way as I did for L2, that we take the income divided by the price of the good on the vertical axis to get that intercept, and the income divided by the price of the good on the horizontal axis to get that intercept. So that is the effect of a change in income. The next slide and figure 3.12 represents the effect of a change in price on the budget line with income remaining constant. Now, with price changes, if there is a change in the price of one good with income unchanged, it's going to cause the budget line to swivel or rotate on one particular intercept. In this example, the price of clothing remains the same. Thus, with the $80 at $2 per unit of clothing, 40 units are purchased if all the income is spent on clothing. However, R1 represents the original budget line where the price of food was $1 per unit, hence the vertical intercept here is 80. So let's consider a scenario where the price of food falls to half a dollar. Now L1 rotates out to L2, and now 160 units of food is purchased. The slope now also changes to become negative 0.25 or minus a quarter. There is thus an increase in the purchasing power of the consumer as the consumer is able to purchase more units of food if they were purchasing more food. However, if the consumer only purchased clothing, they would be unaffected by this change in price of food. If the price of food increases from $1 to $2, as we see in L3, the budget line swivels inwards. The slope has once again changed and is now -1, and the horizontal intercept is now 40. The consumer's purchasing power is now lower than before at L1, and to determine this horizontal intercept, you would say the $80 divided by the new price of food, which is now $2, and that would yield 40 units of food. So this is an example of the effects of a change in price when the price of one good changes and income is unchanged. Of course, there are other scenarios. What if the price of both good changes by the same ratio, or if income changes and prices change? So you need to be able to interpret and understand these relative changes. That concludes week 2.